Starting a new unit today. Unit 3. We're going to be talking about quadrilaterals and polygons. And if you don't know what those are, you will find out in just a minute. So for your do now, you guys cut out this shape and we wanted to line up all the angles together. And this is what my shape looks like once I put them all together, which is pretty similar to what your guys looks like. All the angles together form this shape here. So let's now talk about the questions that I put on the do now page. So looking at the original shape here, how many sides does that original shape have? Outside sides. 4. How many angles does it have? 4. Exactly. So once you put those angles together, like this, are you able to estimate how many degrees do these 4 angles probably add up to?
We have to know how much, like how many degrees goes in a square instead of a triangle.
Yes, we're learning that today. So, how many degrees is that? What shape did it make in the middle when you put all those angles together?
Is it 360?
Yes, it is 360. So what happened is when we put all these angles together, they end up completing a full rotation from A to B to C to D. We have 360 degrees. We have a circle. This will work with any four-sided, four-angled shape or a quadrilateral. That's what a quadrilateral is. It's a shape with 4 sides. So whenever we are looking at the angles inside of a 4-sided shape, they always add up to 360 degrees. Always, always, always. Okay, so that little intro is going to lead us into some notes. We're going to take some notes today, you guys. So I'm going to move this to the side. Just our little discovery activity. And our do now was page 1. So we're going to start with page 2. I'm going to pull these out and get the new sheet of paper. So for page 2 of our notes, I'm going to start by titling my page so I don't lose it. This is Geometry, Unit 3. And still day 19, that's today. So day 19 continued. This is page 2. And I'll give you guys a minute to get your notes out and get ready. If you need a second, pause the video. I'm going to give you a title for this page. So we're learning about a big category of shapes. We just learned about triangles. Now we're going to be talking about quadrilaterals today. So I'm going to title my page Quad. Quad means 4. Trilaterals. Big fancy word. Okay. So in every quadrilateral, there's 3 basic requirements. And here's what those are. A quadrilateral has 4 sides. It has 4 vertices or points, those pointy edges. And there are 4 angles that add up to 360 degrees. these add up to 360 degrees for a quadrilateral. So as long as it fits these three requirements, it's a quadrilateral. So a pretty famous quadrilateral we're all somewhat accustomed to. This is not a perfect drawing, but a square, for example, or a rectangle. But sometimes quadrilaterals don't look as typical as a square or a rectangle. What if I gave you a shape like that? Is that a quadrilateral?
It is.
Yeah.
It is. It's got 4 sides, 4 vertices, 4 angles. Absolutely. Anything with 4 sides, 4 vertices, and 4 angles could be like a diamond. Could be all kinds of different things. Just needs to have those 3 characteristics. So the quadrilateral is kind of the general category of a type of shape. And within the category of quadrilateral, we've got some subcategories. We've got some more specific types of quadrilaterals. And the first one we're going to talk about today is parallelograms. So parallel, P-A-R-A-L-L-E-L, logram. Parallelograms, this is one of our subcategories. It is a type of quadrilateral. So can a parallelogram have 5 sides? No, because it's a quadrilateral. It has to have 4, always. So here are your requirements for a shape to be a parallelogram. And then we'll draw a picture afterwards. So in order for a shape to be considered a parallelogram, opposite sides, sorry guys, we do have a lot of notes today. We're learning a lot of different terms. Opposite sides are parallel and equal to each other, meaning they're the same length. Then we also know opposite angles are equal. They're the same number of degrees. They're congruent. Third requirement is that consecutive angles, and we'll talk about what that means as well. Consecutive angles are supplementary. What big words today? Do you guys remember what supplementary means?
Sure.
Yeah. Creates a straight line, adds up to how many degrees?
180.
180. Good. So in parentheses, I'm going to say adds up to 180 degrees. All right. The last requirement is that diagonals bisect each other. I'll give you guys a minute to write those requirements down, and then we'll draw a picture.
What about the
Hmm?
the quiz? The test.
You want to take it right now?
Yeah.
Mhm.
We can take.
And we're gonna draw a parallelogram. So we're gonna start with a line going straight across, and I'm gonna make it about 1, 2, 3 inches long. I'm gonna make a tilted line right here. I'm gonna make it
How long was the first line? Sorry.
3 inches, I believe. Yep, about 3 inches. And then I made a second one 2 inches long, just at a somewhat of an angle. Then we want to try our best to keep the same angle as we move our ruler over to do the next line. So keep it, try to connect right about here, make it the same length. Bottom too. Got that? You got your parallelograms? Okay, awesome. So let's label all these different things on here. So the first thing that we have written down is that our opposite sides are parallel to each other and they are equal to each other. So I'm actually going to name this B, C, D. So let's start with the side that we have labeled AB. Which side is AB parallel to?
DC.
Yeah, DC. Perfect. So how can we show that these lines are parallel?
A mark on it, like a
So-
little dash.
The dash would say that they're the same length, which we will need to do, but what about parallel?
Ooh, yeah.
You're very close. It is shaped differently.
Oh, you
Arrow.
yeah.
Arrows. Yes, we're gonna go ahead and put little arrows to show that these are parallel. And then to show that they're equal, that's when we do the dash. So I'll put a little dash here as well. So now I know AB and CD are parallel to each other and they are equal to each other to the same length. What about BC?
Parallel to AD.
Perfect. So to show that, we'll do the same thing, but instead of one arrow, since we already used one arrow, we'll do 2 arrows. And since they're also equal to each other, we'll do 2 dashes, 2 tick marks, just like that. Okay. So next we want to look at opposite angles being equal to each other. So we'll start with angle A. Angle A is equal to which angle? C. Perfect. So how can we show that these angles are equal?
Yeah, one line.
Hmm?
You use one line.
One line? Is it like the straight line or the curved line? Yes. So we're gonna draw arcs. Curved lines. A and C are congruent. They're opposite angles, so they're equal to each other. What other set of angles is equal and opposite?
B and D.
B and D. Perfect. So we'll do the same thing, but instead of one, we'll put two arcs. Beautiful. Okay. Everybody got that so far? You still right. Okay. So now we want to look at consecutive angles that are supplementary or they add up to 180 degrees. So consecutive angles are just angles that go one after another, meaning if I start from angle A, my consecutive angle options are the ones directly beside them. I could either do A and B, those are consecutive. I could do A and D, those are consecutive because they're right next to each other. If I'm looking at B, I could do B and A. I could do B and C. So let's write out a few statements and make sure we understand. Supplementary means they add up to 180 degrees. So I'm going to give you the first example. I know that angle A and angle B, angle A plus angle B equal 180 degrees. So let's just go all the way around. Now let's start with angle B. What angle comes next? Yeah, angle C. So angle B and angle C, when I add them together, give me 180 degrees. Let's start with C. What's the next angle?
C and D.
C and D. Beautiful. Angle C and angle D added together give me 180 degrees. And what's my last two that I could put together?
D and A.
D and A. Good. Angle D plus angle A. 80 degrees. Perfect. Okay. Everybody feel okay about consecutive angles and how they're supplementary, how they add up to 180 degrees?
I mean, they're just a straight line.
Yeah, they just make a straight line. Like if I were to look at, or do now. Well, I guess, never mind, this wasn't a parallelogram, so I can't use it. Well, if I cut this up and just put two of the angles together, like A and D, it would make a straight line. That hurt. Okay, now the last thing is talking about something we call diagonals. And that's a pretty simple thing to show you. Let's see what do I want to use. Let's use green. So what a diagonal is it is just a line that connects opposite corners to each other. So I could draw a diagonal going through A and C. This. Here's the diagonal. Other diagonal goes through the other opposite angles. Like that. So we have diagonals. How can I show that these diagonals I drew, the green lines, how can I show that they bisect each other? What does bisect mean?
It's split in two.
To split in two, yes. Whenever I bisect something and I split it in two, what do I know about the size of the two parts that I've made? They're equal, they're the same. So if these diagonals bisect each other, what do I know about the lengths of each of these little lines here?
They're course, right?
Or equal.
The pairs are gonna be equal, so I can't say that this, and this are all equal to each other. But if I'm looking at just line B to line D, right here, this diagonal is splitting it in half. So I'll give you the first one. I'll say that these three, since we already 1 and 2, this part, B to the middle, is the same length as D to the middle, because it's being split in half. Does that make sense? I feel like this is one of the parts that's a little tough to explain. But I think it makes sense when you're looking at it. So what would the other two equal lines be? Yeah, the one from A to the middle and C to the middle. So we would put, since we've already used 1, 2, and 3 dashes, we'll use 4 dashes this time. 2, 4. Okay. That makes sense to you guys? If not, we can talk about it. Absolutely, we can. So this is all the rules of parallelograms. So let me give you an example problem, because I think knowing this information, y'all know how to do this. Let's say that you are given the measure of angle A, and I tell you that it is 60 degrees. I want you then to find the measure of angle B, the measure of angle C, and the measure of angle D. I feel like you know where to start. Okay, I'm going to pause it and let you guys try that on your own for a minute, and then we'll talk about it once you're done. Can we find out without doing any math? What do we know already?
You might see.
You can find
C.
and it is? You were about to say it. I interrupted you.
Oh, C equals 60.
Yes, C equals 60 degrees. And we know that because they're opposite angles, so they are the same. So C is 60 degrees. Beautiful. Now, how are we going to find the other two?
I subtracted 60 from 180.
Yeah. Okay, and what did that give you?
120.
120. Perfect. Did you
I
guys
was
get that too? You're right. 100% correct. Did you two get that also? Awesome. Yay. So we might not even really need to go over that too much. Y'all feel good about it? Good. Just in case, for funsies, making sure we do understand it, I'll write out the equation. So we knew that A and C were the same because they're congruent. And to find B and D, first of all, they are the same. They're congruent because they're opposite angles. But we could use these formulas up here. Since consecutive angles are supplementary, they add up to 180 degrees. I could do angle A plus angle B, or I can do angle A plus angle D equals 180 and plug in for A. So if A is 60, I could do 60 plus B equals 180. And we just solve minus 60 on both sides. And we get B equals 120 degrees. And we know B and B are the same. So, girl. So, you guys rock. Okay. I'm gonna let you guys have a minute if you're still writing that down. And we're gonna go on to the next page of notes. Oops. Take my paper. Okay. Clear it out. Some of them. We can get it out. This one. Okay, so page 3, day 19. Oh, it's still. Yeah. Okay. So we just learned about quadrilaterals. We learned about parallelograms. Parallelogram is a type of quadrilateral, but now we're going to go even deeper into the quadrilaterals and the parallelograms. And I'm going to give you 3 types of parallelograms. It's going even further. So I'm going to title this page Types of Parallelograms. So parallelograms. Okay. And the first type we're going to talk about is a rectangle. Oh, or to the side, I'm right. Rectangle. Now, I'm sure that you all know what a rectangle might look like. I'm sure you can picture one in your mind. There's also some requirements that we might not have really thought about. So let's see. Let's start with talking about the angles. So a rectangle is a parallelogram. Opposite sides are parallel, opposite sides are equal, all of that. The diagonals bisect each other, same requirements. But the other thing about a rectangle is that not only are opposite angles equal, but all angles, so all angles are 90 degrees. And because all the angles are 90 degrees, the diagonals that we can draw inside, diagonals are equal to each other. Not only do they just split each other in half, they're also equal to each other. And draw a picture of a rectangle. So for my rectangle, I'm going to make first side 1 inch Then I'm gonna make my longer sides 2 inches. I need to make all my angles about 90 degrees, or as close to a perfect 90 as possible. I'm doing a 1 inch by 2 inch rectangle here. Like my vertices A, B, C, D. So now we just want to make sure that we're labeling all the things up here. So our angles are 90 degrees. How do we show that?
Put it squares.
Yeah, by putting a little square in them. So I'm gonna put a little square on all my angles like this. You know what? I'm actually gonna add one more note on here. Because this part's pretty important too. It is already defined in parallelograms, but I think it's also something that is good to recognize for rectangles is that opposite sides are equal. So how are we gonna label our opposite sides as being equal? With the little lines, I'm gonna put 2 on A, B, and D, C just because they're longer. That you could put 1 and 2 on the others. But I'm just gonna put my little dashes on my congruent side lengths. I want to label the diagonals. So remember to draw a diagonal. All we do is put our straight edge crossing through opposite angle at the vertex. And we just draw a line from end to end. The diagonal from B to D and from A to C. Show that the diagonals are the same length. Instead of doing tick marks like I did in the parallelogram, because we were just showing that they bisected each other so the different halves were equal. Since I'm trying to show the whole line is equal to the whole other line, the diagonals, I'm going to write a statement underneath instead. So it's a little less messy. I'm going to write the line AC is congruent or equal to BD. It's talking about my diagonals. Perfect. Okay, two more shapes. The next shape, the next quadrilateral, is what we call a rhombus. Y'all ever heard of a rhombus? Yeah, somebody, yes. So it's spelled RHOMBUS, rhombus. Yes. We have two main requirements. First of all, it does follow all the parallelogram requirements, but we also know that all four sides are equal. And diagonals are perpendicular. Do y'all remember what perpendicular means?
They're the same.
You might be thinking of parallel.
Do they cross in the middle?
So yes, perpendicular crosses in the middle, but it crosses at a certain angle.
90 degrees.
90 degrees, good. So diagonals are perpendicular, and I'll put in parentheses, cross at 90 degrees. All around.
Can I step over and look at my phone? Because my sister has my son. It's just, I don't know what you think of it.
All good, all good. Okay, so we're gonna draw a rhombus now. I'm gonna make it just 1 inch on each side. I'm gonna start with like a tilted line. The same length, 1 inch. Other line, pretty close angle. Same length. And here's my rhombus. I'll give you guys a minute to copy that. Not perfect, but it will work. Once you've got that drawn, we're gonna label our equal sides. All four sides are equal. So how many tick marks do I need to have on each side?
For the
1
top
on
and bottom.
2, 2 on 2.
1 on 2 and 2 on 2?
Yeah.
You could totally do that, but if they're all four equal, we could put the same number on all four of them, couldn't we? So I guess it doesn't matter what number you put. You could put 1 on all four of them. You could put 2 on all four of them, 3 on all four of them, 4. Usually we start with 1 for the first thing that we're saying is congruent. So I'm going to label mine by putting just 1 dash on each side to show that these are all the same length. Large diagonals. Through opposite angles here. And how do I show that these are perpendicular?
You can go underneath and you will first have to label your side. Like A, B, C.
We could do that. Yeah, let's do that. A, B, C, and D. A, B, C, and D. Okay. So, how do I show that lines are perpendicular? You remember when we did the perpendicular bisector? And we would make them cross at a certain angle? We put in the angle to show that it's a certain degree.
The square.
The square, yes. So remember, perpendicular just means that these are crossing at a 90-degree angle, right? You can see it here. It lines up the edges with my edge of my ruler. It should be about 90 degrees. So to show that it's 90 degrees, we just draw that little box inside of it like that, or that little square. Makes sense? Okay.
So if you asked to find like an angle like right there, they would all be 90.
Always. In a rhombus? Yes. Always, always. Perfect. Okay, and then we have one more shape, and that's gonna be the end of our notes. I know we wrote a lot today, guys. We wrote a lot. So the last one is square. Maybe the simplest one of all, but surprisingly is actually the most specific quadrilateral that I believe that we have here on this list. Here. What do y'all know about the angles in a square?
They're all right.
They're all right angles. They're all 90 degrees. Good. So all angles are 90 degrees. What do you know about the sides of a square?
All equal.
Yes, they're all equal. Square is maybe the easiest one. All sides are equal. Perfect. And we're just gonna leave it with those two. And we know that a square also follows all the rectangle and rhombus rules, because a square is technically just a more specific rhombus. It's technically just a more specific rectangle. Does that make sense to you guys, or is that confusing? It's like it falls into the subcategory. It's just a more specific version. So let's draw a square and we'll label it. And I'm gonna make my square about an inch, kind of like my rhombus. So I'm really just gonna label my angles as being 90. And I'm gonna label my equal sides. Your square should end up looking pretty similar to mine. So you've got that. That is the end of our notes. Putting these to the side, I'm going to give you your exit ticket. And guess what? I printed out copies for you guys. You don't have to draw it. So for your exit ticket, I am giving you the measure of an angle. I'm giving you the measure of two sides. You need to find the rest of the angles and the rest of the sides, which using all the rules that we just talked about, this is a parallelogram. You will be able to find these. So I'm going to pass this out to you. And when you finish, you are free.